Hi everyone, Dr. Gray here. Today we are working on Waves Target 4, understanding how waves act and interact, understanding the behavior of waves caused by reflection, refraction, and absorption, and understanding how reflection and absorption of light produces color. And today, excuse me, we are looking at understanding how the behavior of waves is caused by reflection, refraction, and absorption. And really we're just going to look at reflection because the focus of this lesson is the reflection by convex and concave mirrors. So before we get into drawing ray diagrams for convex and concave mirrors, we've got some vocabulary that I want to make sure everybody's on the same page with. The first term that we're looking at is optical axis. And the optical axis is a straight line drawn outward from the center of a mirror, similar to the normal when we were looking at specular and diffuse reflection. We also have the focal point, and this is going to be marked with a capital F, and it is the location on the optical axis through which all incident parallel light rays are focused. There is the focal length, and that's just going to be the distance between the mirror and that F point, or that focal point on the mirror. And then we have two types of images that are produced. A real image is an image through which the light passes and can be projected on a screen. Whereas a virtual image, the light or the image could not be projected onto the screen. And as we go through the examples, I will explain more about real images and virtual images. So first let's look at the three types of mirrors. The mirror that you're probably most familiar with, this is just a plain mirror. This is the bathroom mirror or the rear view mirror in your car. These are all plain mirrors. And plain mirrors produce images that are otherwise identical to the original, other than in the reflected image from a plain mirror, the left side will be reflected on the right side of the reflection, and the right side will be reflected as the left side of the reflected image. But top is still top and bottom is still bottom. In a concave mirror and a convex mirror, so these are our curved mirrors, and they have a variety of applications. Probably the most common one that students are familiar with are funhouse mirrors, but concave and convex mirrors are also used to make your side view mirrors on your car, or you sometimes see them when you walk into a variety. There'll be a curved mirror that kind of allows the cashier to see the entire store looking in just that mirror, and so they have some useful applications. Now, what I want to point out is the way that I draw mirrors. And so you can see the curve in our image here. These lines that are pointing out from the back, that indicates the back side. The lines are always on the back or the back side of the mirror. And so in a concave mirror, we have a curved mirror, and the reflected side, so this is the reflecting side. The reflecting side is sort of cave-shaped, and hence the concave part of the concave mirror. In a convex mirror, so we have it curved still, except now the curved or the reflecting side is pointing out towards you. And these two types of mirrors do two different things, or produce two different types of images. So let's look at the types of images that they make. So first I just want to go through the rules for how to do ray diagrams we're going to start with concave mirrors first. And these rules will be on the pages when you do the practice, so let me just go through them first. The first rule is we're going to draw a ray, and a ray is just an arrow. It tells us the direction the light wave is traveling. So we're going to draw a ray from the top of the object parallel to the optical axis, and this ray is going to reflect through the focal point. Then we have two choices here. We have to decide, we should put a little or here. We have to look at, well, is the object beyond the focal point, or is it inside the focal point? Is it between the mirror and the focal point, or is it beyond that? So if the object is far from the mirror, and that's what it means if it's beyond the focal part, so this is far from the mirror, well then we'll do step 2. We will draw a ray from the top of the object through the focal point. it will then reflect parallel to the optical axis. On the other hand, if the object is close to the mirror, if it's inside the focal point, we're going to draw a ray through the top of the object as if it came from the focal point. And then this ray will also reflect parallel to the optical axis. And now where the two rays, where the ray from step 1 and the ray from step 2 or 3, depending on the object's placement, where those two rays intersect, that shows us where the image is formed. All right, so let's look at a couple of examples using concave mirrors. And so remember, a concave mirror, the reflecting side of that mirror is cave-shaped. And so our first step is to put in an object. And so let's see, I'm going to draw a little tree here. Right? Not a good tree, just a tree. And the first thing that we're going to do is we're going to draw a ray, so we're going to draw our arrow from the top of the object parallel to the optical axis. And this, by the way, is the optical axis. So we draw our ray parallel to the optical axis, and it reflects through the focal point. So it's going to bounce off that surface and reflect through our focal point. And it really should go through that line. So make yours go through that line. Now, the next step, we're going to choose either step 2 or step 3. And so we look at this first one, and our focal point is here. Our object is outside the focal point. Here's our object, here's our focal point. So it's far away from our mirror. And so we're going to use just step 2 here. We're going to draw a ray from the top of the object through the focal point. And so from the top of the object through the focal point, when it comes in contact with the mirror, it's going to reflect parallel to the optical axis. And so it's going to reflect this way. Now, the image is formed, here's our rule, the image is formed where those two rays intersect. And so here's our intersection point, and so our tree is going to be inverted. Because it's now upside down. It is a real image because it's in front of the mirror is the way to think about that. It's produced by actual rays, not virtual rays. And in this case, it's hard to see here, but it's going to be larger than the original. So this is essentially a magnifying mirror. When the object is outside of the focal point of that concave mirror, that mirror has the effect of flipping that object over and making it appear larger. Now, what if we are inside the focal point? Let's see if I can draw this easier. Let's maybe put a heart there. And we'll put that heart, it's now inside our focal point, so it's between the focal point and our curved surface. And so the first rule always applies. We're going to draw a ray from the top of the object parallel to the optical axis. So here's the top of our object. It's parallel to the optical axis, and it's going to reflect through the focal point. And so we're going to draw our reflected ray that way. Now, step 2, we're going to the second part of this, so we're not going to do step 2, we're going to do step 3 because our object is close to the mirror now. And so for this one, we're going to draw a ray through the top of the object as if it came from the focal point. So here's our focal point. There's the top of our object, or thereabouts. It's going to reflect parallel to the optical axis, so it's going to reflect this way. Now, when you look at these two rays, they're moving away from each other. They're never going to intersect, and we need them to intersect in order for us to know about that reflected image. And so what we're going to have to do for this one is we're going to reflect them in the virtual direction. And so we're going to just extend them backwards. And so I'm drawing these with dashed lines so that we'll see that they're virtual images. And now if we look at where our image is, it's still above our optical axis line. So it's still a normal image. It's not inverted, except now it's behind the screen. And so it's a normal image. It is upright, except now it is virtual. Because it is forming behind the plane of the mirror, you could not reflect or you could not project this heart on a screen like we might do for a projector. And it is clearly larger. This one's obviously larger than the original. Okay. So now let's look at convex mirrors. And so convex mirrors, remember, are the ones where the reflecting surface is pointing out at you. It is like the backside of a spoon. And for the rules for doing ray diagrams with convex mirrors are the same. So we don't have to worry about where is the object relative to the focal point. There's the same two rules for all convex mirrors. And if you look at these, the rules are very similar to the ones we saw before. We're going to draw a ray from the top of the object parallel to the optical axis, and it's going to reflect through the focal point, exactly the same as when we did concave mirrors. Now the second part of this now is we're going to draw a ray from the top of the object to the optical axis. So we're going to draw it from the top of the object to the optical axis at the mirror. And then this ray is going to reflect according to the law of reflection. Then we're going to have to extend the reflected ray in the virtual direction in order to see those two intersect. And so let's try a couple of these. So we're going to start out and we're going to make, that heart worked pretty well, so I'm going to do the heart again. Let's do the heart here. And so now we're going to draw a ray from the top of the object parallel to the optical axis. And so here's our object, there's our optical axis. It's going to reflect through the focal point. So it's going to go that direction. Now the second part is we're going to draw a ray from the top of the object to the optical axis at the mirror. So it's going to go from here to there. Now it's going to obey the law of reflection and reflect off of that mirror and head. We want to keep the incident angle and the reflected angle the same. And so we need this angle here to be the same as that angle there. They're pretty close, not quite the same, but they'll do. And then we're going to have to extend the reflected ray in the virtual direction. And so we're going to extend it this way to see where those two rays are going to intersect, because clearly this arrow and this arrow are not going to intersect in the normal direction. But when we extend this ray in the virtual direction, then we do get an intersection of those two rays. It's again above the line, so it's still upright. And there would be our reflected image. And so this image is normal. It's not upside down because it's formed above the line. It is a virtual image because it's formed behind the mirror, so we could not project it onto a screen. And it is smaller than the original. Now let's see if that changes any if we put the object further away from the mirror. And so let's move, we'll do it with an arrow this time. We'll put our little arrow out here. All right, so we're going to follow our rules again. Draw a ray from the top of the object parallel to the optical axis. I may have made this one a little too big. Let me extend my mirror here so I have something to reflect it off of. All right, so we're going to, from the top of the object to parallel to the optical axis, and then we're going to reflect it through the focal point. So it's going to go down this way. And then the step 2, we're going to draw it from the top of the object to the optical axis at the mirror. It's going to reflect off the mirror at the same angle that it hit the mirror. And it's going to, then we have to extend it in the virtual direction to see where they intersect. And then our reflected image is formed where those two objects intersect. And so here's going to be our reflected image. And we see that it is also normal, still upright. It's not flipped over. It is still virtual. because it's behind the plane of the mirror. We could not project it onto a screen. And it is, again, smaller than the original. That's it for today. I'll see you in class.